So you can also create a firewall policy that covers application traffic. So a firewall policy where you can identify the types of application traffic you want coming to and from the network. And so, for example, here, let's go back here, we're setting up application traffic here. What kind of application traffic are we setting up? Well, notice that I'm allowing FTP, SMTP, SSH, Telnet, and HTTP. We're accepting over here incoming packets for these services right here. So I'm actually establishing a policy with respect to applications with our firewall. And remember, all this is going to do is this is the practical implementation of the organization's policy. So this has already been set up, hopefully, by an organization that says, look, we're going to allow connections to FTP, SMTP, SSH, and so on. Okay, this is an application traffic matrix. Here we're talking about the service FTP. The internal host is Windows, location any. Host security policy client only, antivirus, firewall internal security policy permit, firewall external security policy deny. So what this is saying is that we're denying, let's say we're permitting, I don't know why they're using permit here rather than allow like they did before, but we're allowing internal access to the FTP server, but not external. So if this were an FTP server, we're allowing this connection over here, but not this connection here. How would you reflect that? Well, you're going to have one rule here that doesn't allow anything coming in to this FTP server, but here you're going to have a rule that allows these computers to access this FTP server. And this just gives you examples of some of the other things. FTP, I'm not sure exactly why. This really doesn't make a difference except in how things are implemented. You know, what type of firewall is implemented. If this is going to be sitting on a, well, never mind, because this is going to be sitting on a packet filtering device anyway. And this is showing the location, who's allowed to access these different services. Here this says location any, so we're permitting the internal for all 4 of these services. Anybody on the internal network are allowed to access these services. And over here, if you have an application proxy where users are authenticating from the outside, then they're allowed to access these services, but they're not allowed to access NetBIOS over TCP/IP. So firewalls enable you to control access to your computer or network, and we've already talked about that, by controlling access to particular applications, and that's very easy to do just by controlling the firewall rules. And oops, I'm sorry about that. I was thinking, let's go back here by doing this. By establishing your firewall rules here, and by where you place them within your firewall perimeter. So we've already talked about options for defining rules. We allow traffic, we block traffic, or we ask or prompt. That's usually used for host-based firewalls. We want to keep the list of rules as short as possible. And you know, that really depends. You can have 5 rules or you can have 100 rules. You want to limit the number of rules because it becomes very tricky in managing these rules, because it's not very easy to go in and determine where a problem is, or whether you're having a problem or not just by looking at the rules if you've got 100 or 500 rules. So if you can keep the rules as short as possible, it's going to be a lot more efficient and a lot more easy to manage. And we process the rules in a particular order, starting from the very first run. So if we look at this here, the first rule that is going to be is, let me see, actually it's going to be this rule right here, accept ICMP anywhere, anywhere. This is going to be the first rule that's looked at. When a packet comes in, it's going to be compared against this, then this, then this, then this, then this, then this. And the first time that one of these rules matches, let's say it's this one right here, whatever rule number that is, and so it's a new incoming packet to destination port is port 21, then that packet is no longer compared against any of these other rules because it's already matched this rule. So the most important rule should be at the top of the list, and the last rule is the cleanup rule. It's a catch-all type rule, and there's different ways of defining this, and that's as we'll see. Recall that we talked about the default policy of allow or deny. If we look back here at this rule, the default policy right here is to reject. If nothing matches in here, then we're going to reject it. So our default policy here is reject. As we'll see later when you look at the iptables videos, that you can actually put that at the top of your firewall rule list as a policy. Okay, that's too tiny to look at, so we're just going to skip over. And actually explain a little bit more about how the packet filter works in iptables and how it works through here. Essentially what this is doing is that the internet packets come in here, they hit the firewall, and then the firewall looks at the packets and headers and starts comparing them to the rule-based firewalls. And so the first question, does the packet match a rule, or does the cleanup rule apply? Yes, and the packet should be allowed to pass. Yes, then it's allowed into the protected land. Otherwise, it's just dropped right here. However, if it comes in and doesn't match the first rule, no. Is there another rule? Then it just keeps comparing the rules and rules and rules and so on. And we assume here that there's a default policy at the bottom that's a catch-all rule, so that this will always end up being yes somewhere. So if a packet comes in and doesn't match any of these rules, this will always apply, because notice how this says all protocols, source is anywhere, and the destination is anywhere. So that rule will always apply to every packet. Okay, you can filter by IP addresses. So you usually use CIDR notation in order to do that, and I'll talk a little bit more about that in the iptables videos. And of course you need to identify your trusted networks. That is the ones that are going to have the least restrictive firewall rules, and those are going to be the ones on your internal LAN. And that's what this essentially says right here. The firewall should allow traffic from trusted sources. And this is zone alarm, and it's showing how to just set up your trusted source right here. So usually zone alarm is very good about identifying that for yourself, but if you have other trusted networks, you can go in and actually specify this in here. So this shows you the starting IP address and the ending IP address. So this trusted network is 10.10.56.0. And you can use to control internet services. We've kind of already talked about this. You need to understand here web services, the ports involved in that. With DNS, what ports are involved. Email, what ports are involved. This is showing outbound web access. And let me just mention one thing. There's two types of filtering, and I've already alluded to this before. There's ingress filtering and there's egress filtering. Ingress is packets coming from the untrusted network, that is the internet, into your trusted network. Egress filtering is looking at the packets from your internal network going outbound. So this is egress filtering right here. And so this is showing something coming from the internal network, HTTP, the source IP address. So this is an internal network. We really don't know the destination IP, but we do know the destination port because we're talking about HTTP, so we're going to allow that. If it's secure HTTP and the source address is this, so notice that this is different. I wonder if they did that on purpose. I think that's a typo. I think that's supposed to be the same. 207 right there. The source port is any, and the reason we have to define the source port as any is because this is going to be a randomly chosen port above 1023, of course. We don't know the destination IP, but we do know the destination port because we're talking about secure HTTP. So it's port 443, and we're going to allow that. And we want to set up for domain name service here. Notice this is both outbound and inbound. And so this is all going to be over port 53. Now, why didn't they do that over here? Okay, now they're just indicating a single address here, a single address. But notice that we need to include TCP as well as UDP because DNS will work over TCP as well as UDP. So we need to indicate that as such, and we're going to allow all those connections. And some more examples, and I might just let you look at this yourself. Let me see if there's anything important in here. Not really. Okay, so you can just take a look at that in your notes. With FTP, you've got active FTP and passive FTP, and so passive will actually use a single port, whereas passive use two ports, port 20 and port 21. So you have to be careful depending upon what type of FTP you're allowing, either active or passive, as to which port you're going to open. Here are the FTP rules. Controlling inbound is going to be on 21 right here, and notice 20 right here, and notice passive right here is going to use a single. What did I say? I can't remember what I said back here. Passive is only going to use should be only a single port, and whereas active uses two ports, 20 and 21. And so if you're setting up passive FTP and you've got this these two rules instantiated, then it's not going to work if you're just using passive FTP. So you need to understand the difference between those. Okay, I'm going to skip over some of these because this is just stuff that A, you should either know, or B, you can just read and understand yourself. There's no reason for me to explain this. But you should look at this, especially some of these examples. They might be useful for the rules that you set up for your assignment. Okay, ICMP message types, as we saw before, there's very many different ICMP message types. And once again, it's used for errors. It's a housekeeping protocol. So some of these you want to allow and some of these you don't want to allow, perhaps. And this just shows you source quench, echo request, echo reply, destination unreachable, redirect, destination unreachable, and so on. Notice this says denied to all of those. That might not be a good idea. If the administrator, of course, this also says internal and external. Two over here indicating where the source is. Okay, filtering by services. Rules should follow a few general practices. Firewall with the deny all security policy should start with a clean slate. That is, you're going to dump all your firewall rules and you're just going to start all over again. And as we'll see here, for example, if I were to go in and I'm going to add a rule for the input chain, and this will be much more understandable. Whoops, -J drop. If I were to do this, essentially what I'm doing here is I'm adding this to the end of this input chain, which actually it should be Red Hat Firewall -1-input. But I'm just using it as input here. This would be something incoming from the internet to the local network. Since I have this deny right here, this is going to be added after this reject. This is going to be added after the reject, which means that that rule will never be seen. So essentially what I need to do is to start all over again and to actually go in and add this rule somewhere up here above it, because once again, if I just add this right here, it's going to append it to the input chain, and so it will never be seen because it's after this one that's all encompassing. So you need to start with a clean slate here, And there's a way to dump these rules, and we'll see later on, the way to dump all the rules is to do flush like this, or you can do -F, which means that there are no firewall rules anymore. They've all been dumped from kernel memory. This is showing typical packet rule base that you can take a look at yourself. You go through here and see if you understand it. Notice here at the bottom, I'm assuming this is the bottom. This looks like 1, 2, 3, 4, 5, 6, 7, 8. Notice this any deny. This is deny by default, and that should be the last rule because that's going to match everything. Okay, now we're going to just see a few configurations for setting up a firewall. We can look at a screening router, dual home host, screened subnet, multiple DMZs, multiple firewalls, and a reverse firewall. This is really looks like it's going from the simplest to the most complicated. So a screening router determines whether to allow or deny packets based on their source and destination IP addresses or other information in their headers. It doesn't stop many attacks. And so if we want to look at what this looks like right in here, most of what you use at your probably at your house looks something like that. So this is like a screening router packet filter. Is it just comes in the source and IP address, destination IP address and port are used to screen. Dual home host computers, a dual home host has been configured with more than one network interface. So you have one network IP address coming in and another one coming out. And only firewall software can forward the packets from one interface to another, which means that the firewall rule has to look at each packet in order to determine whether it should be forwarded to the second interface. And it's we see right here what this has got. So what we have is the firewall right here. And notice here he's got this firewall, this little wall right here, but he doesn't use it over here. Interesting. Okay. So notice here you have the external interface, and here you have the internal interface. Notice this internal interface is a private IP address. And so the packets come in here on this external interface, and then if any of the rules match, then they're forwarded to this internal interface, which then forwards the packets on back here to the Ethernet backbone within the internal LAN. Now we have something called a screened host, which is similar to a dual homed host, where we can add a router between the host and the internet to carry out IP packet filtering. And it can function as a gateway or a proxy server. So here we have our simple packet filter right here. And notice that this has the external IP address of this. Over here we have the internal IP address. So now the packets have to go through both a simple packet filter right here that's configured to look at IP addresses, and then we have one right here that may have more complicated configuration. So what you're getting in here is defense in depth. Not only do you have to beat this, but you also have to beat this. And of course you can have a screen subnet demilitarized zone. The DMZ is a subnet of publicly available servers placed outside the internal LAN, and we saw pictures of this earlier. It's called the service network or perimeter network, and we can have a firewall that protects the DMZ right here. Notice here now that we have a 3-homed host. We have 3 different network interface cards. This is sitting on a single computer or device. So we have the external interface right here. Notice that we have the screen subnet router right here. This is screened because it is allowing in a subset of information that's coming in here. And so notice here that you can actually get into the internal LAN from the internet according to this, but notice that it has 3 different interfaces. So if we get even more complicated, we can have multiple DMZs and firewall configurations. For example, for use with a server farm, where you have a group of servers connected in their own subnet, and they work together to receive requests with the help of load balancing software. And load balancing software prioritizes and schedules requests and distributes them to the different servers. So let's take a look at this right here. Notice that we have multiple DMZs in here. We have this little simple screening router that's right here, and anything coming into the internet right here. would go through this screening router, which would allow it access here to the mail server and the web server. Here we have a business partner across a subnet where a business partner would access this DMZ through this screening router and would allow them access to directory server and file server. And down here, packets coming into this subnet, this DMZ would have access to the media server, FTP server, and communication server only after going through this screening router. And then over here, we've got a firewall on this side, which then allows us to access the internal network. So notice now that you're getting more and more complicated, you have screening routers right here, you have firewalls right here, and you have firewalls right here. Which do you think is the least restrictive firewall? It's going to be these. And probably the second most restrictive are going to be these. And the most restrictive is going to be this firewall in general. The further you go into the network, the more restrictive your rules are. You can protect a DMZ with 2 or more firewalls. One firewall controls traffic between the DMZ and the internet, and the second one controls traffic between the protected LAN and the DMZ, and I thought we just saw that. So here we have network coming into the screening router. We have the external interfaces right here. So you're going through another layer of firewall back to another router right in here, which then allows you access here to the internal LAN. Here what we're doing is we're going through another firewall down here to get to the this is going to be supposedly a DMZ, and this is a DMZ right here. Let's just keep going because this is actually more of the same thing, only getting a little more complicated. It's kind of if you go through the first 3 or 4, they're kind of start looking the same, although they have different configurations. But it does show you how you can set up multiple firewalls to add multiple layers of defense and depth, depending upon how much access you want to allow to each of the services. And reverse firewall, we've actually already alluded to this, is monitors connections headed out of a network instead of trying to block what's coming in. And essentially, that's good to do because there's some things that you don't want getting out. For example, you don't want somebody accessing a P2P network somewhere, and so, well, actually, that would be blocking them coming in. There may be certain IP addresses. Essentially, what you're trying to do here is you're trying to filter out unauthorized attempts to access things that you don't want people to access out on the network. Okay, this gives you a list of firewall configurations, advantages and disadvantages, pretty much in order of complexity, except the reverse firewall, you're actually going to have to do that for your assignment. We're going to be blocking stuff incoming as well as outgoing. So you're going to be doing ingress and egress filtering. But you can take a look at this yourself. Looking at the advantages of the screening router, it's simple, it's cost effective, but it provides minimal protection. All the way down to if you have branch offices with multiple firewalls, provides protection for all offices in a corporate network, but it's a lot more expensive to configure and to install and to manage. So anything on down here is going to be a lot more expensive. It's going to be a lot more complicated than looking at things up here. So which one do you use? Well, it depends upon what you're trying to protect, and that's why you need to identify your services, your corporate goods, and you do a risk analysis to determine what you want to protect and how, and only then would you go in and select one of these to protect your corporate assets. Okay, so that ends this discussion of firewalls. The next thing you should do, if you haven't already, is to read to view the iptables videos. And once you do that, you should go back and review the iptables videos. And once you do that, you should go back and review the iptables videos. Hope you're getting the hint here. What I want you to do is to make sure that you understand iptables, because it's going to be part of your assignment.